For this particular chi-square test, we're going to work with a situation where the percent distribution is not given to us, and we can figure out exactly whether or not we're going to reject or not reject the null hypothesis based upon the information. So let's read the problem and see how we're going to set this up. A supervisor at Fast Track Professional Temporary Services, Inc. suspects that her employees are more likely to call in sick on Mondays and Fridays than the other days of the week. To test this claim, she collects data on the number of people who call in sick on each day of the week. Her data is summarized in the table over here. We want to test the claim that the relative frequency of days in which employees call in sick is not equal for the 5 days of the work week. We're going to use a 5% level of significance. Does it appear that the absentees are not equally distributed across the 5 days? Well, again, we have the number of employees who call in sick each and every day, and that's our observed value. We want to find our expected value. Well, since the percent distribution is not given to us, we want to be able to determine if the number of people who are calling in sick every day is approximately the same. So the relative frequency will be approximately equal. So in order to be able to do that, we go to our formula to determine how many people actually called in sick, that we're going to take the sum, and therefore we add up the frequency of the number of people who called in sick, and that tells us we have 47. Therefore, our expected value would be that it would be approximately the same every day to contraindicate the fact that they're not equal. So in order to have their equal every day, we take our 47, and we want that a fixed cell. We divide that by 5 since they're 5 work days per week. And we figure out approximately 9 4/10 people are absent per day. We copy this straight across, and that gives us that information. Now we want to write down the null and the alternative hypothesis. So for the null hypothesis, we're going to look at the claim, and we say the number of, or actually, let's call it this way, the relative frequency of days in which employees call in sick is equal for all 5 days. And the alternative hypothesis would say the relative frequency of days in which employees call in sick is not equal for all 5 days. Well, now we want to be able to find the p-value, and we're going to get it from our chi-square dot test formula. So we go to our formulas, we go to statistical, and we go to chi-square dot test. And again, all we have to put in are the actual test values and the expected values. And you notice they're the same. And that tells us that we are close to 60% of the time, the distribution is approximately the same. Well, now that we have our p-value, which is the same as the chi-square test value, we have to compare the p-value to our alpha. So remember, our p-value is the one that we just calculated, which is approximately 60% of the time. The alpha is the 5% that's given to us in our particular study, and we want the numbers to look approximately the same. And when we look at these two, we see that the p-value is greater than our alpha, which leads us to believe that the relative frequency is approximately the same for all 5 days. Therefore, for our conclusion, we say there is insufficient evidence to suggest that the relative frequency or frequencies are not all equal. Therefore, we do not reject the null hypothesis. And here again, just to remind you that since the relative frequency is not given to us, and it says that they will call in sick not equal for the 5 work days in the week, we would say that it all are approximately the same.